So now we're going to get into chemical cycling and how that is going to work in an ecosystem. This is definitely one that us humans are doing a great job of screwing up, shall I say. All right, so I'm going to just show you these different cycles, and we'll talk about how they are going to work. So this one is a basic one. This is the water cycle. So you've seen the water cycle since probably second grade. And so as you know, the oceans are going to evaporate, and then they're going to condense, and they're going to cause precipitation, right? Same with terrestrial water. So that's going to basically be the way that the water cycle works. However, what we're doing is we're taking water from one area and putting it into an area that doesn't usually have water. So think about like swimming pools in Arizona, golf courses in Arizona. Probably not what naturally would be there. I know that's shocking. So what happens is we take this water, we ship it over to these places, then it's going to evaporate into the sky up there, but it's not going to rain down back there, it's going to go somewhere else. So it's a constant process of us bringing that stuff back in, right? So that's why we really shouldn't be messing with the water cycle that much. This next one is going to be the carbon cycle. And the carbon cycle is something that you've heard about in the news quite a bit, I'm sure. And so the way that it works is the way that carbon is going to get into the atmosphere is a couple of different ways. Cellular respiration, so that's the carbon dioxide that we breathe out just by being alive. And then you've got burning of fossil fuels and that type of thing. That's going to put carbon dioxide up into the atmosphere. Now, the way that carbon dioxide is going to get out of the atmosphere is through photosynthesis, right? So it's going to pull it down, and they're going to convert it into glucose, and then we can use it in our ecosystems, either in the oceans or over here in the forests. But another thing that's happening is it's sinking into the oceans and making the oceans a little bit acidic because the carbon dioxide is just sitting in there. Now, what's crazy about us as human beings is that this is what we're doing. We are cutting these things down, and we're burning more of these. So we're kind of screwing up the carbon cycle because all the carbon is building up in our atmosphere, and that's one of the contributing factors to global warming. So that's a cycle that we really should be a little bit better about. Now, the next cycle here is going to be the nitrogen cycle. This is a little bit more of a complex looking one, but it's not too bad. So what happens is plants really like to take up nitrogen, but it has to be in a special form for them to take it up. So the way that nitrogen is going to get into the soil is some of it is going to come down from the atmosphere in rain and that type of thing, but also it's going to be excreted either in our, poop and pee, that kind of thing, and also from, dying organisms. So the thing I want you to notice about this is all these little circles are going to be pictures of bacteria. And that's because bacteria are essential to the nitrogen cycle. So what's going to happen is the nitrogen, all right, so what's going to happen is when we urinate and things like that, and it gets into the soil, that's going to be in the form of ammonia. And what's going to happen is there's going to be bacteria that are going to actually do what's called nitrification. And they're going to take that and convert it into nitrites. And then eventually there's going to be nitrifying bacteria that are going to change it into nitrates. Now, the reason this is important is because especially in aquatic systems, these forms, ammonia and ammonium, are very toxic to fish. So if it doesn't get taken out by that bacteria, they could kill themselves with their own excrement, which is not a pleasant way to die. And that's usually why people's fish die in a fish tank, because they don't know any better. It's that they should be changing the water out because they probably don't have plants in there taking it back up. So what happens is the bacteria, if they're present, are going to convert it into that nitrite. Now, nitrite isn't as harmful to fish and also things living in the soil. But what's even better is when they change it into nitrates. Plants love nitrates. It's almost like fertilizer to them, and so they'll pull it up. And that's why the bulk of fertilizer is actually based on nitrates. Okay? So all of this is the way that the cycle should work. However, we are doing things like making synthetic fertilizers and interesting stuff that we'll get into in the next chapter. And what's happening is a lot of nitrogen is ending up in the atmosphere and not as much is getting fixed down here. And so we're poisoning the soil, and we're also causing acid rain to form up here. So that's why we're concerned about the nitrogen cycle. Now, this is going to be a picture of the phosphorus cycle. And phosphate is going to enter an ecosystem through the weathering of rocks. So rocks are going to have phosphates in them, and then precipitation is going to make that run off into waterways and into the ground. And what happens is we use phosphates all the time, right? If you think about ATP, ATP is adenosine triphosphate, right? So we need it. Living organisms need it. And what'll happen is when we die, there's going to be phosphates, and so the plants will take them up, and we've got a little cycle happening here. Once again, plants love phosphates, and that's why a lot of fertilizers are going to be based on phosphates in addition to nitrogen-based ones. Now, what's crazy is we want plants to grow like we want our golf course. We want to have that nice grass that doesn't belong very many places, right? So what we're going to do is we're going to put fertilizer on it. We're going to put tons of phosphorus and nitrogen on it. And what's going to happen is the plants aren't going to be able to uptake all of that. So a lot of it is going to run off into the little lakes and things nearby. That's when you're going to see an algae bloom because there's plants living in that water that are like, oh, sweet, nitrogen and phosphorus, thanks. And they're going to go crazy, right? So we're completely skewing these cycles and bringing things to places that they don't belong. And that's what the real problem is. Okay, so let me get back to our notes. Those are all of our cycles that we talked about. And what we want to really get into is how we can have an impact on our environment. So we really need to be doing stuff to be more effective citizens and deal with the problems that we've been causing. So one thing that farmers are trying to do is they're trying to do crop cycling, which is what these pictures are trying to show. So you can see the house is in the same little part and so are the cows. But you can see that the crops have been cycled. And that's because plants are going to take up different amounts of different things at different rates. And so if you cycle them like that, then you may not have to worry about fertilizing as much. So that's a great way to be a little bit more responsible. This picture here is just showing grading that sometimes they'll do, and that has to do with the way water runs. And so if they do the fertilizing up here, then they can count on the water to bring the fertilizer down to these other spots. So maybe they can use less that way. All right, let's get back to the notes and see where we are. Talked about that, talked about that. Okay, combustion of fossil fuels. So here's something that we're really having a problem with. Acid rain. Acid rain is going to be where you've got chemicals that are in the atmosphere and they're going to be mixing with the rain clouds and it's going to create an acid. And now when I say an acid, it doesn't mean that in areas that have acid rain that your skin's going to bubble and, blister when it rains. But it is causing problems for the plants because it's making the soil too acidic and now the plants can't survive. So it's definitely an issue that is directly related to burning fossil fuels. So the more that we can decrease our use of fossil fuels, the better with that case. Another thing that we're doing, because we're just going to rip on humans in this chapter, is we're dumping toxins into ecosystems. And this is becoming a huge problem. And that's what this is a picture of here. So you heard about how the bald eagle was almost extinct. Well, the reason that the bald eagle almost went extinct was because of DDT. DDT was a pesticide that we used back in the 50s, I want to say. And what they did is they literally had planes that had this stuff. It was like a powder. And they would just go over neighborhoods and just drop this powder everywhere. They have pictures of people like sweeping it off the front porch like it's snow. And they're like, oh, this is awesome. I just have to sweep it away and I don't have any mosquitoes. Then all of a sudden, birds started dropping out of the sky. And they were like, oh, I don't think that's a good idea, right? So what was happening was something called biomagnification. And so that's what this is a picture of here. So what I want you to get out of this is you've got phytoplankton that, okay, so let's say we've got our DDT, and our DDT is running off into a lake. So that's going to be heavy. It's going to go down to the bottom. So you've got these bottom feeders, and they're going to eat it. Now it's going to become part of their fatty tissues because that's what that chemical likes to do. And so now every little piece of phytoplankton that you see here has a concentration of 0.025 parts per million in their system. Not a big deal, right? I mean, it's not great, but not a huge concentration. However, if these zooplankton start eating these guys, they're probably not going to just eat one or two. They're probably going to eat a whole bunch. So what's going to happen is the amount of that chemical is going to jump up because these guys have eaten a whole bunch of these guys. So now it's gotten a little higher. Now these fish come along and they eat a whole bunch of these. Now you can see it's jumped up a ton. So when you get to the top of the food chain, Look at how high that is from where we started. So that's going to be biomagnification, and that's what happened with eagles, is they were eating fish that were tainted with that DDT, and the side effect of it was when they were making their eggs, the eggs were actually so thin on the shell that when the eagles were sitting on them to incubate them, they crushed the babies and killed them. So now we've banned DDT, and now I'm sure you've heard that the eagle has been taken off the endangered species list. Amazing how that works, right? Now, another problem that has been linked to biomagnification is the amount of mercury that's in fish. Mercury is a heavy metal that was being dumped into the oceans. It still is in some places. And what happens is the same thing. And so you've got tuna, sharks, tilefish, these big predators, and they have very high amounts of mercury in them. So that's why, like, if you're pregnant, they always tell you to, limit your fish intake, especially certain ones, because mercury is linked to birth defects. So don't worry. Now they're talking about at supermarkets, you can get your own little test kits, so you can actually test the fish that you bought to see how much mercury is in it. Isn't that creepy? All right, so that's going to be biomagnification, kind of scary stuff. Another thing that's going along is the greenhouse effect, and that's going to be causing global warming. So I've got a graph here that's kind of interesting to take a look at that has a correlation between global temperatures, which are going to be that red line, and carbon dioxide levels in our atmosphere. So in my eyes, that shows a pretty close correlation, and this is what is causing global warming to happen. Why do we care about global warming? I mean, wouldn't it be nice if everything was warm? That's not what global warming is. That's why we're kind of going more towards calling it climate change. And that's because the climates are changing. All those currents we talked about are changing. And if the Gulf Stream doesn't keep going up the coast of the U.S., we're going to have a very cold coast of the U.S. So this is a huge issue, and it has to do with that carbon cycle that we were talking about and the fact that we are using more fossil fuels and cutting down more trees that could soak them up. So that's why we have that carbon issue. And I know I'm depressing you, but we are going to end on a high note, I promise. The last thing we're going to talk about is that hole in the ozone layer. So this graph is showing the thickness of the ozone layer, and you can see that it was nice and thick. And then around the late 70s, early 80s, it started to really, really get thin. The reason for that was because of a chemical called chlorofluorocarbons, or CFCs. And that was found in refrigerants and aerosol sprays and that type of thing. So I apologize. My hair in the 80s was definitely due to aerosol hairspray. We didn't know, so I apologize. But I did have amazing, really bad hair. So anyway, what happened was they figured it out and they put a ban on CFCs. So we saw a thickness start to happen in the ozone layer. The thickness is getting better, so I know this graph is a little misleading, so I'm going to go away from it so we can end on our high note. But the ozone layer is getting thicker. The hole is getting smaller. Now, the reason we care about the ozone layer is because it's like a layer of sunscreen around the Earth. So if it gets thinner, then we are going to see higher rates of mutations in our DNA, cancers, coral bleaching, and that type of thing. And they've seen the rates of skin cancer skyrocket since the ozone layer has gotten thinner. And especially in areas like New Zealand where the hole is really, really thick, the hole is really big, that's where they see a really high amount of skin cancer and that type of thing. But the good news is that the hole is getting smaller because we're being more responsible. So we're starting to see some sort of benefit from our actions to take action against this stuff. So that's the high note I'm going to leave you on.